Here lies the promise of biofuels, the expanded cultivation of crops that require lower inputs and fewer equipment operations to produce high sustainable yields of biomass rich in organic carbon compounds that can be readily converted into fuels. One such crop is sugarcane. Brazil devotes about 10% of its farmland to sugarcane, and ethanol from sugarcane supplies about 14% of its fuel needs for vehicles. Sugarcane serves as a host for nitrogen-fixing bacteria within its tissues and therefore maintains high productivity under relatively low nitrogen fertilization. Farm management of sugarcane, like that of other biomass crops, must balance the practice of leaving stubble in the field to return vital nutrients and organic carbon to the soil against the practice of removing this material to serve as an energy source during processing. In Brazil, a large portion of the above-ground biomass is removed from the field and burned at the processing plants to provide both heat for distilling the alcohol and electricity to run the machinery. Still unknown are the long-term sustainability of such a practice. A major controversy concerning growing maize and sugarcane for ethanol or soybeans for biodiesel is the diversion of food to fuels. In the last 2 years, the boom in maize ethanol in the United States has contributed to a 50% increase in maize prices. These price increases resonate throughout the food chain, causing higher prices at the market because maize is a major foodstuff for meat and dairy cattle, and corn syrup is a major ingredient in many human foods and beverages. Another potential biomass crop, one which grows on lands unsuitable for cultivation of human foods, is switchgrass. Switchgrass produces prodigious quantities of biomass that is 33% cellulose, 26% hemicellulose, and 18% lignin. One can convert these constituents into ethanol with varying degrees of difficulty. Some scientists reckon that nitrogen, other chemicals, and water requirements for sustainable production of switchgrass are less than a third that of maize, where others reckon that the input requirements for both crops are somewhat similar. On this supposition and a few others hinges the future of the biofuels industry. In summary, number 1, battery technology limits the amount of energy that an electric vehicle can carry and thus its speed, range, and recharge time. Number 2, at current gasoline prices, an owner may not recover the additional capital costs of hybrid power plants over the life of the vehicle. Number 3, modern engines have the flexibility to combust mixtures containing biofuels. 4, biofuels are not neutral with respect to greenhouse gases because their production and use deviates significantly from 100% efficiency.